Assalamu alaikum students. I hope you are fine. Today we do the exercise 2.4. As we earlier discussed the laws of exponent in the previous lecture, now we do some few sums for it related to exercise 2.4. As I have written already the question number 1, we use laws of exponents to simplify the sums given in exercise 2.4. So let's begin with this part 1. And in part 1 we have a value 243 raised to power minus 2 by 3, 32 whole power minus 1 by 5 whole divided by 196 whole power minus 1 square root. In this question we have different bases with different powers. Powers are negative, as well as we have a radical value in denominator. So let's deal with it. First of all, we convert this composite number 243, 32 and 196 into their prime factors. 243, when we take its LCM, as it is an odd number, so we begin with the division 3. 3 8s are 24, 3 1s are 3 2s are 3 7s are 3 9s are 3 3s are 9 and 3 1s are. We have 5 times 3, which is equal to 243. So 3 multiply 3 multiply 3 multiply 3 multiply 3 whole power minus 2 by 3. 32, now we take its prime factors by using method of LCM. 2 16s are 32, 2 8s are 16, 2 4s are 8, 2 2s are and 2 1s are 2. We have again 5 times 2 in the product. 2 2s are 4, 2s are 8, 2s are 16, 2s are 32 whole power minus 1 by 5. In denominator, we deal with the 96 as a composite number, so we take its LCM 196. As it is an even number, so we divide by 2 first. 2 9s are 18, 2 8s are 16, 2 4s are 8, 2 9s are 7 7s are 49, 7 1s are. So we have pair of 2 and 7. 2 multiply 2 multiply 7 multiply 7 whole power minus 1. We convert the radical form in exponential one, so that becomes whole power 1 by 2. In the next step, according to law of sum of powers, 3 raised to power 5 whole power minus 2 by 3. In the same way, 2 raised to power 5 whole power minus 1 by 5 whole divided by 2 raised to power 2 multiply 7 raised to power 2, because if bases are same, then the powers are added. So 2 2 times and 7 2 times, we have the powers. Law, according to law of power, minus 1 multiplied to the 1 by 2, and that becomes minus 1 by 2. Let's move to the next step, and in the next step we apply law of power in numerator for 3 raised to power 5 multiply minus 2 by 3. 2 raised to power 5 multiply minus 1 by 5. 2 raised to power 2 multiply minus 1 by 2. But which law we apply over here? That is law of power of product. As the values are different in a product and having common power, so we apply law of power of product. And according to that law, power 2 multiplied to the minus 1 by 2 and power 2 multiplied to minus 1 by 2 as well of the 7. So 7 raised to power 2 multiply minus 1 by 2. In the next step, 3 raised to power minus 10 by 3 multiply 2 raised to power minus 1. Why? Because 5 and 1 by 5 are reciprocal, so 5 were cancelled. So 2 and 2 as well as in the 7 power 2 are cancelled. So it becomes 2 raised to power minus 1, 7 raised to power minus 1. Now we apply the law of quotient power with same base to make all the powers positive in numerator as well as in denominator. So it becomes now 2 raised to power 1, 7 raised to power 1, 3 raised to power 10 by 3, multiply 2 raised to power 1. Let's move to the next step. Two raised to power 1 becomes 2, 7 divided by 3 raised to power. As this is an improper fraction, 10 by 3. So we divide 10 by 3 to get a mixed fraction. 3 3s are 9, 1. So we have 3 whole number into 1 as a numerator and 3 as a denominator. So now 10 by 3 will become 3 into 1 by 3 multiply 2. We have same numbers in numerator and denominator, like values we can cancel. Let's move to the next step. 7 divided by 3 raised to power 3 multiply 3 raised to power 1 by 3. Why we are allowed to do this? Because according to the definition of a mixed fraction, that 3 into 1 over 3 can be written as 3 plus 1 by 3. Because when we take the LCM of these two, so we get what? 9 plus 1, that is 10 by 3. So it means we are allowed to write as 3 plus 1 over 3. And if we write this as 3 raised to power 3 plus 1 over 3, so it means we apply the law of sum of powers over here and we get what? We get 3 raised to power 3 multiply 3 raised to power 1 by 3. So we directly do this, and what we get over here, 3 raised to power 3 means 3 multiply 3 times and we get 27 multiply third root of 3. Why? Because in the previous lecture of exercise 2.3 we discussed that the 3 is indexed because the power is in a fraction and denominators determine as index. And we write in radical form 3 raised to power 1 over 3, that is written as third root of 3. That is what we learn in exercise 2.3. So that is our simplified answer using laws of exponent for the part 1 of exercise 2.4 of question number 1. So let's begin with the question number 1 part 2, and that is 2x की power 5 y की power minus 4 multiplied by minus 8 x raised to power minus 3 y raised to power 2. So let's begin with this question. As we observe that the two algebraic expressions are given in a product form, bracket means multiply, so we multiply both of these expressions using laws of exponent. According to the basic concept, sign is multiplied to the sign. We have plus and minus sign of the second expression. So plus multiply minus, we know that simple rule, plus multiply minus is equal to minus, so therefore we get minus over here. Number multiplied to the number, secondly number multiplied to the number, so 2 multiply 8 we have 16. Variable multiplied to the variable, but same variables. Here we have x multiplied to x. Law of sum of power is applied over here, so bases are same when they are multiplied, so the powers are added. So x raised to power 5 plus minus 3. Secondly, y multiplied to the y, so we get what? Y raised to power minus 4 plus 2. Finally we get minus 16 x raised to power 2 y raised to power minus 2. As we know that we have to transform every negative power into positive one. So therefore we apply the law of quotient of power with same base, according to which negative power will become positive. Minus 16x raised to the power 2 divided by y raised to the power 2. And that's it. Now we do the part 3. In part 3 we deal with the two different algebraic expressions having different powers. We apply laws of exponent. According to B. Demas rule, we have to solve the internal part of the bracket first. So let's begin with this. As we compare the same basis, x, the bigger power is 4, so therefore smaller power minus 2 move to the denominator. So according to law of quotient of power with same base, that minus power taken to denominator will become positive 4 plus 2. Minus 1 is greater than minus 3. So therefore for y, minus 1 retain its place, and minus 3 move to the numerator. For z, 0 is greater, so therefore z remain in denominator, and the power minus 4 move to denominator, whole power minus 3. Y raised to the power 2 by adding x raised to the power 6, z raised to the power 4, whole power minus 3. Now we have a simple fraction having common power. We apply the law of power of fraction. According to that law of power of fraction, y raised to the power 2 multiply minus 3. The common power of the fraction become power of the numerator and power of the denominator. Power of the denominator. Now we do what? We apply law of power product in denominator. The common power of the product will become the power of each variable. So x raised to the power 6 multiply minus 3, z raised to the power 4 multiply minus 3, and in numerator we multiply these numbers, so we will get what? Minus 6. In the next step we get y raised to the power minus 6 whole divided by x raised to the power minus 18, z raised to the power minus 12. We have negative powers for each variable. To make them positive, we apply law of quotient of power with same base. According to that law, the negative powers will become positive when moved from numerator to denominator or denominator to numerator. So let's move them. Y raised to the power 6, it is taken to denominator, x raised to the power 18, z raised to the power 12 it becomes, and that is the final simplified